Hello everyone, I am Geeta, Assistant Professor, Department of Mathematics, SNS College of Technology. In this session, we are going to discuss about reduction of quadratic form to canonical form. First of all, what is quadratic form? A homogeneous polynomial of second degree in any number of variables is called as quadratic form. For example, 2x1 square minus 2x2 square plus 4x3 square plus 2x1 x2 minus 6x1 x3 plus 6x2 x3. All its degree is 2. Here also 2, 2, 2. So adding x1 power 1 and x2 power 1 we get degree 2. Likewise the remaining terms also degree 2. So which is called as quadratic form. Now next we are going to find the matrix of this quadratic form. So, for the given example, the matrix of the quadratic form is A is nothing but coefficient. First row is coefficient of x1 square plus half into coefficient of x1 x2, half into coefficient of x1 x3. Likewise, half into coefficient of x2 x1, coefficient of x2 square, half into coefficient of x2 x3, half into coefficient of x3 x1, half into coefficient of x3 x2, then half coefficient of x3 square. Using this formula, we convert this quadratic form into the matrix form. Here, the diagonal elements will be powers x1 square, x2 square, x3 square. Its coefficients are 2 minus 2, 4. Remaining will be divided by 2 and substitute here we get the corresponding matrix A value. Now, we are going to discuss about nature of the quadratic form. Already we know the procedure for finding eigenvalues and the eigenvector. If all the eigenvalues are positive means the quadratic form is positive definite. If all the eigenvalues are negative means the quadratic form is negative definite. All the eigenvalues are positive, one of the eigenvalues 0 means it is coming under semi-positive definite. Likewise, all the eigenvalues are negative. One of the eigenvalue is 0 means that is coming under negative definite. Remaining cases we get it is indefinite. Right? Working rule for quadratic form to canonical form. First, we have to find the matrix of the quadratic form. After that, find the characteristic equation, then eigenvalues and the eigenvectors. Next, we need to find the normalize the matrix N. After that, we need to find the N transpose. Then diagonalize the matrix. D is equal to N transpose into A. After that, its canonical form is y1, y2, y3 into D into y1, y2, y3. Multiplying these three things, we get its canonical form. Now we are going to see one problem based on quadratic form to canonical form. Here we are going to reduce the quadratic form q is equal to 6x square plus 3y square plus 3z square minus 4xy minus 2yz plus 4zx to reduce this quadratic to canonical form and also we have to find its nature. First we need to find the matrix of this quadratic form. Using this formula, instead of x1, x2, here we are having xy. So, first coefficient of x square, after that half into coefficient of xy, then coefficient of xz. Likewise, the remaining values we need to find. The diagonal elements is nothing but x square, y square, z square values. So 6, 3, 3 here. After that, coefficient of xy is divided by 2 means we get minus 2. If it is minus 2 here now, then second row, first column element put also minus 2. Next, x1, x3 value, xz value is 4 here divided by 2. We get 2 here. So xz is 2 means corresponding zx value also 2. So this both diagonal these two elements are same. So likewise we find the remaining values. Here the matrix A is 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3 here. Next we are supposed to find the characteristic equation. Already we know the concept. The characteristic equation of 3 by 3 matrix is lambda cube minus s1 lambda square plus s2 lambda minus x3 equal to 0. Here s1 value equal to sum of n diagonal elements, it is 1. s2 equal to sum of minus of n diagonal elements, it is 36. s3 is determinant of a, that is equal to 32 here. After finding the characteristic equation, solving this characteristic equation, we get the corresponding eigenvalues 2 to 8 here. Here we are having repeated eigenvalue. Now we are going to find the corresponding eigenvectors for this repeated eigenvalue. So first we need to find the non-repeated eigenvalues eigenvector here. So if for finding eigenvectors, we should solve a minus lambda into x equal to 0. So a minus lambda into x equal to 0. So multiplying these two, we get this system of equations here. Let it be a here. Putting lambda equal to 8 in this equation, we get the equation. In these three equations, we consider 2 and 3 because three equations are different. Considering 2 and 3, using cross multiplication rule, we get x1 value is 2 minus 1 here. After that, we need to find the corresponding eigenvector for the eigenvalue lambda equal to 2. Substitute lambda equal to 2 in system of equation A, we get the three equations. Here all the three equations are same. So here we consider any one of this equation. 2x1 minus x2 plus x3 equal to 0. Putting x1 equal to 0, we get x2 value is 0, 1, 1. After that, let us consider x3 as element which is orthogonal to x1 and x2. Using this concept, x1 transpose x3 equal to 0, x2 transpose x3 equal to 0. Using this, we get equations 8 and 9. Solving 8 and 9, we get x3 as 1, 1, 1. After that, in last class, we discussed about diagonalization. First, we need to find the normalized matrix, then n transpose. After that, the diagonalized matrix D is nothing but n transpose an. We get 8, 0, 0, 0, 2, 0, 0, 0, 2. This is our diagonalized matrix. Here the diagonal elements are nothing but our eigenvalues 8, 2, 2. After that, we go to canonical form. Its canonical form is y1, y2, y3 into d into y1, y2, y3. So multiplying these three things, we get 8y1 square plus 2y2 square plus 2y3 square. Here all the eigenvalues are positive, hence its quadratic form is positive definite here. Thank you.